Welcome to is the third part of RS1000. And then, this is a Typhoon special, so we do not, I do not want to show my camera. I do not want to show my face during the typhoon. So I'm at home to prepare this line. Hopes that you will still think it's good enough. And then we will have a questionnaire this week. So I will ask whether the lecture is good or not, my face on the video is good or not, you want to see my face or not, and then the online exercise and face-to-face exercise is long or not. Okay, so we have this kind of questionnaire and they ask you the details about our setting and how we can improve. So this lesson, I would like to special thanks my colleagues in Department of Computing is Dr. Richard Lui. So most of the slide are reference to the Dr. Richard Lui. So he did a really good slide in regressions and also the customing. So I just create a tutorial. I just create a tutorial that is related to the healthcare data, and then most of the slide is from Dr. Richard Lui. So I would like to thank him and then acknowledgement, give a acknowledgement to him. So brainwashing sessions, machine learning model, ML model and algorithm. So machine learning model is going to find out the rules, the relationship between your input and output. So they try to abstract all the things out and then find out the relationship, whatever is image or whatever is data. So they want to find out the relationship behind the input and the output in an abstract way. So because they find the relationship between the real data, so really important that you have to find the data set, okay? You need not to find an expert to cook all the data, to cook all the rules, but you have to find out the data, as many as you can. So in our past lab exercise, we do a small data collections. Honestly, it's not really enough, right? So you find that there is no incorrect image, there is not enough correct image, etc., etc. Yes, the largest database you can find, the more powerful algorithm. I would say that the more powerful model that you can obtain. So you have to collect more and more. But definitely, I guess is your tutorial side is only for your learning process. I'm not. I think it's not good to ask you to do 300 data or 500 data, and then you need to import them one by one and then record them using 2 or 3 hours to do it. It will be your nightmare, and then I don't want to do it. So it's just a learning process. But honestly, when you go out to work as an experiment or as a research, you have to prepare these kind of things. And most likely, if you learn the programming, it will be your advance to process all of them in an automatic way and then in a really smooth way. So there are lots of algorithms that you can use, and then neural network, artificial neural network or deep learning is only one of them. So inside the AI, inside the machine learning, you still have support vector machine, you still have the fuzzy model, etc., etc. There are lots of different algorithms that you can choose. Neural network is only one of them. So we have touched the classifications, right? So cats and the dogs, and then different posture of your frozen shoulder, etc. So now we would like to move to another part. So still we are inside the big set, the superset of supervised learning, and then we'll move to regressions. So the difference between the classifications and then the regressions is classification. They are using discrete data. So cats, dogs, they do not have a linear relationship between cats and dogs, between the poster 1, poster 2, etc. But in regressions, we are talking about the continuous data. So continuous data starting from 0, 1, 2, 3, 4, 5, 6, etc., etc. So those are the continuous data. So those can be put into x-axis and then starting from 0 into infinity, or from positive infinity to negative infinity. So they are the continuous data. And then for the continuous data, we will not return cats or dogs. We'll return a number as a result. So even, for example, you want to estimate my salary, even in your data set, you do not have a $71,551.25, etc. Right? You do not have this kind of data, but by using the regressions, they can still give you a number, not a descriptive data. It's a number. They have the ability to regress a number for you, and that is regressions for the continuous data. Yeah, and then here we'll start our next part, regressions. So in a easy understanding, regressions can be used to predict something that is related to number. Definitely is about the money. So in this exercise, we were talking about the house. Yeah, Hong Kong is still famous about the house, about the pricing of the house. So yeah, we were talking about house. Another kinds of the usage will be a stock market. So there are lots of regressions model that is going to predict the stock market, the value, or today whether I should buy or sell, or the amount of the stock market, etc., etc. We want a number. With a number, so we are able to do our investment. So it's really important. It can be put into medicines. So loss of the dosage or loss of the amount of the drugs. So you need to have a linear regression. So how many amounts I should give to a diabetic patient, how many amount I should give to a, maybe you are PT or OT, not only a drugs, physical exercise, extra medicine, right? So how many one of the exercise I should give to the patients. So this is also a regression because they return how many ones, right? It returns a number, it returns a numeric value. Yeah, cells. So definitely there are lots of the Chinese CHA, right? CHA company. For example, I can't remember their English name, or maybe I use a Western style, right? Starbucks. So their Starbucks, they need to estimate their sales. They need to estimate how many goods I should ship to one physical store. So this kind of sale is also an estimation. And then in China, lots of the Chinese company, they put it into another extreme. So they will have the steel stock, and then nearly all their stock, all their goods shipped to the physical store can be used out within 1 year or 1 week or within few days. They want all the things be very fast, and then they want to keep all the things in very good condition. So how to keep the things in a good condition? So you need to have the planning, and then send the goods to different stores. And then this kind of planning, this kind of estimation is a sales estimations. So it's based on the demographic data of your clients. It's based on the sales or promotion of your store, and then estimate your customer behavior and estimate the sales. It's really important because it's turned around into a best or better management issue. So yeah, when you're watching your YouTube, TikTok, or other short videos, right? So the video recommendation is also based on the regression model. It's also based on how many similar videos that you have watched, and then how many percentage of this kind of videos that you like it or not. So again, return to the percentage is also a video recommendation, and then it also fall into a regressions model. So to easy understanding the regression model is why you have the output, right? You have the output. And then for the regression model, you will have the input value x1, x2, x3, etc., etc. It's really similar to your neural network. You also have the input and the output. Input x1, x2, x3 is the dependent variables, and then y will, x1, x2, x3 will be the independent variables, and then y will be the dependence variable. And we will say that is estimate value. So you will have different input to estimate one output usually. And then yeah, so if you are running the linear regressions, so y equals to mx plus c, So if you are using the linear regression, so it will be very easy to understand. But honestly, linear regression is only one model algorithm of the regression model. You can have different kinds of this kind of model. If you want to learn more, you can study more. But in our course, we're only talking about the linear regressions. Yeah, so we will have the attributes, and then most likely the attributes will be the numeric variables will be the numeric variables. So if they are not numeric variables, so somehow you need to do the clustering first. So that's why in these lessons we'll combine the regressions and clustering together. Because if say that if you have the male and female, so how to put a male and female into a linear regressions is really hard, right? And even now you have a lot of different gender, right? You have LGBTQIA plus, etc. So you have to find a best way to do the clustering to turn it into different group. And then with the different group, and then you do the regressions, and then with the regressions, and then you can have the estimate wide. So the numeric number can be the price, can be a size, can be a wave, whatever. It should be a number. Okay, so that is very important. So in our lecture of these lessons, we are not only using the healthcare problem, so we use a problem that all the Hong Kong people in our whole life we are always looking for is the price of housing. Okay, price of housing. So we can input the number of rooms, the size of your house, how many square feet. We are not calling square meter, we are calling square feet, very small, right? And then the distance to the close school. So if you have the children, so definitely is one of the concern. Or your price is, your price, the value is identified or defined by how many famous school in your district. So this kind of value can be put it into regression model, and then finally we can estimate the house of the house price. Okay. So yeah, that is the y value, and that is the input value that we want to put it x1, x2, x3, and then y value. So we need to collect the data, the real sales of the house, the data. So how many? It's easy to find in all the property websites. So they will list out all the sales within this 10 years, within this 20 years or more. And I guess 10 years should be still useful to estimate the price, but 20 years is not, right? So they will have the number of rooms, they will have the price, they will have all the information you want. So all the things that you need to collect the data and then change the value. And then this one again here will be the feature, and then you will want to estimate the price. So this one is the target variables. So we put it into our system and then train up the relationship. So this is a regression. We want to regress, right? We want to output predict a number. For example, if I have a room that is I have a house that with 3 rooms, right? So what is the estimate price? So definitely if you have the 3 rooms, should be if it's in the same area, on the same floor or close in the same building, the floor is on the same floor, so almost should be within 200 and 400 right now, right? So this is the estimate price. And then we want to find the relationship, and then we will use the regression model to train up the relationship between number of rooms and then the price, and then finally we can estimate our result. So if you only looking at the number of rooms and then the price is here, so number of rooms will be the independent variables 0, 1, 2, 3, 4, 5, 6, etc., etc., and here is the price, and then the price will depend on the number of rooms. Okay, so if it's in the same buildings and then on the same floor, so most likely the relationship is easy to estimate. So you can see that, so all the things will be close to a 9. Okay, close to a line, and then we can use a linear regression to estimate and then predict the price of the house by using a straight line. And this one is the most easiest to understand, is linear regressions. Okay, so with 2 values, 1 y and 1 x, we can plot a graph. So what about with 2 input value? For example, we have the x1, x2, so somehow we can still plot in a 3D graph, whatever in Microsoft Excel or in the Stat Kingdom, Stat Kingdom tools. So most likely we can do it 4-dimensional, 5-dimensional, or even 100 or 1 million dimension. We can still do it, but plotting or visualize the graph is not so easy. And for the human, honestly, 2D is the best, okay? To understand the relationship of all sorts of things, for a normal people, 2D is the best. 3D is still acceptable, but if you move to 4D, 4-dimensional or higher dimensional, it will be hard for a normal people to understand. So honestly, for the researcher, they are always want to looking at more and more parameter. So yeah, if you want to estimate the house, definitely the size is a matter. So number of room close to the famous school or not, and then the maybe also the estimate salary of each family. So yeah, we close to the MTR station, etc., etc. You want to collect X many input, X1, X2, X3, X many X you can. Not all the thing is useful, and then if you collect the data, it takes time. Filter the data is take time. Pre-process the data is take time. So honestly, if you really want to do similar things, yeah, you will increase the number of your workload. And then when you put it into a machine learning model, it also takes time, and then it also takes the computation power to run all of them. So think carefully before you collect the data, because yeah, if you just collect all the thing data as many as you can, definitely it will be your nightmare. And the most important thing is, yeah, especially in healthcare or in this kind of research, healthcare research, you should read the literature. You should do the literature review. You should read the paper. Find out the most important factor that is affect the output data before you start your experiment. So that is really important. And then if you have many data come out, usually we will have lots of 2D graph. We will not have lots of the 3D graph to plot out the relationship of 2 parameter or 3 or 4 or 5 parameter into one graph. Is really hard to understand. So usually we will list out all the 2D one by one, and then we want to find a linear regressions. We want to find a relationship. If we can find a straight line, that is perfect. But if it's still, we can find a plan, or we can find a curve that can identify or find a, I don't know, it's not a straight line, maybe it's hyperbola or parabola. Still, we can say that you have achieved a really important research output, because you have find out the correct factor, you have find out the relationship, and then you have find a line to separate the data into different relationships. So yeah, that is really important. And then in these sessions, we are not going to ask you to do lots of nonlinear approach. So you will not see a curve, you will not see a hyperbola or parabola in your exercise. So most likely we'll only use a linear regressions. Okay, linear regression, that means a line, y equals to mx plus c, whatever from the new network. That is the previous lessons to this lessons. We are always talking about the linear regressions. We are talking about y equal to mx plus c. So I guess you know how to plot the graph, right? So for example, if I have a y equals to mx plus c, and then we have the x, which is independent variable, 1, 2, 3, 4, 5, etc. And then you will have another output. So you know how to put the x and then calculate the y, right? So it's easy. I need not to repeat, right? So this one will be used in your Excel, in your face-to-face and also online exercise. So honestly, the situation is really easy to understand. You have the x in this exercise, in this example, you have the input x. So this is one of the data, another data, another data, another data. So we plot all the points on a xy relationship. When you plot the graph on the xy relationship, so you can see that, hey, it looks like a straight line, right? So should be there is a line here, y equals to mx plus c, that can represent the relationship of the room and then the price, and that is linear regression, the starting of the linear regressions. We put all the data distribution on a 2D graph first, on a 2D graph, and then we want to find a relationship. And then it's good that this relationship is a line linear. Yeah, and that is something that we want, y equals to mx plus c, right? So we want to find a line that can pass through all the points. Yes, we want to find to do it. But honestly, for the real data, when you have lots of this kind of points, it's not easy to find a line to pass through all the points. You can just estimate a line and then think that, hey, this line should be right there. And then we put it as a straight line and then say that, hey, this is the relationship of our data. And then this is a y equals to mx plus c linear equation, and then whether the m equals to slope and then c equal to the intercept. So some of the slide or some of the paper, they will use b extra bias. That means the beginning values. So by tuning the slope m or by tuning the y-intercept, so somehow we can have a line. But honestly, the line here is right there, right? So can I say that the line is a little bit here, changing the slope, or changing the y-intercept? The answer is yes, right? But how can we find the best line to represent this relationship? For the housing price prediction, so we have the y equal to 2x plus 4. And next, the price equal to 2x plus 4, we can estimate the price of 3 rooms, we can estimate the price with 5 rooms, etc., etc. But honestly, it looks good, right? But can we have some scientific way to estimate the error and then find the best slope and also the best y-intercept? Is our machine learning and AI have to do it. Honestly, the slope and the y-intercept you can present in different ways. So yeah, the point is here, the distribution is here. So if I change the slope into 0 and then the y-intercept into +2, so the line is still here, right? And then if we change the y-intercept to 8 and then the slope x -1, so it also passes through some of the line. So which one, A, B, C, which one is the best? And then how we can use a scientific way to present. How good of a model of a linear regressions? Honestly, we are talking about error again, right? So we want to find the small error. So here, the dot is the real data set. The dot is the real data set. So we find a line here, linear regressions, right? Linear equations, and then pass through all the line. If the line is perpendicular to the point, so the distance, or we say that the distance in between the point and the line to the minimum error, we call it is a better good model. If the distance between the point and the line is they are large, they are far away from each other, we say it is not a good model, it's a bad model. And that is the error function, right? So the error function, or you call it the cost functions, so it's measure the small value to the best model to the right. Okay, so we are going to measure here the distance between the point and the line. Honestly, in your quiz or in your final quiz, right? Final quiz. So we are not going to ask you about what is the definition of error and then what is the definition of cost, etc. So we will just give you the data and then we will just ask you to calculate the error. So starting from last exercise, last face-to-face and then on exercise, you have the calculations, and then this lab exercise, you have more and more calculations, so you can understand the style of our final quiz. So we are not going to ask the definition. We want you to understand the reason behind, and then we want you to understand the situation. So honestly, starting from these lessons, you cannot simply just use a calculator. So that's why we'll have the Excel, we'll have the statistic kingdom, we'll have the tools, and then help you to do the calculations. Okay. The meaning is we want to repeatedly calculate the error, and then we don't want you become a calculator. We use a spreadsheet for you to calculate. Okay. The error E is easy to understand. So you are going to calculate the difference, the value between the real data, okay, and the estimate value. So that means that when you have a 9 here, y equal to mx plus c, the intercept, then we can have the real values and then the estimate value, and then we can calculate the difference between the real value and then the estimate value. So the estimate value here is still y equals to mx plus b, right? The slope and the interception, the linear equations, that linear regression that you can get, and then calculate the error between the real value and then estimate value. And we calculate the error one by one. So in this exercise or in this example, so at least you have 1, 2, 3, 4. You have 4 points of the error that you can sum up them together. So to present it again, so it's called absolute error. Absolute error, so it's calculate the distance between the points and also the line. So we add up all the error together. So here is the distance of point 1, distance, sorry. So here is the distance of point 1, distance of point 2, distance of point P, distance of point 4, etc. So we add up all the distance together. So here, why this one, we call it a beta estimations of the linear equation, because can you see that the distance between each point here is smaller, smaller, and smaller. So by adding all the errors together, we find that this one is a better model because the error is smaller. And that is how we calculate the error and then find the best linear equation to fit all of your data. If you do not want to use the absolute value ABS, so somehow you can use the square value. So you can use the square value and then you can do the calculation. The reason we use the absolute ABS, absolute value, or the square value, because we want to minimize or we want to engage the negative sign, okay? Because here, sometimes when you use the estimate point minus the real value, right? So sometimes they may be negative, sometimes they may be positive. So we don't want to have this kind of negative and positive. So we have the ABS or the square error. So whatever you are using the ABS, absolute sign, or the square error, so the purpose and then the results are almost the same. Just like you take a square value and then you take a square root, and then yeah, the values is more or less, or I would say that the meaning is exactly the same. There is another way to calculate the error is using the angle, but honestly, yeah, using the cosine angle. But honestly, when you are drill into this kind of error estimation is one of the research topic, then you will learn more about this kind of process in our Excel exercise or in our face-to-face online exercise. Most likely we use the Excel and then we use the absolute size, ABS size, because it's easier. Otherwise, you take the square and then you take the square root in your final quiz, it will be it will be your nightmare. Okay, so similarly, so this kind of the square error is they try to find out the difference between the estimate value and then the exact value, and then we use the square area concept to sum up all the things. And yeah, with a small area, so it will be a small error. With a small error, that means it's a best or better model. So if you want to have a look with the square error or have a look with the absolute error, so somehow you can pause the videos here and then calculate 0.1, 2, 3, 4 in your exercise. So it will be a good exercise for you to calculate the square error of a linear regressions.